We're going to look at what they call fundamental counting principles. So we've been given our question here, and I kind of I shortened it so that we can read through it quickly and just pull out the important information. So our high school has a soccer team. So this stands for essentially we have 6 defense. Okay, we have 7 people who are in the midfield. So we'll use colors to help us kind of determine what is what. And we have 3 people who are strikers. And then finally we have our 2 goalies. Okay, and they ask us, how can we start a game with a 1-4-4-2 formation? So what we're going to do is we're going to kind of set up blocks here. So the first block we'll set up for goalies. Okay, and that's where our 1 is. Our 1 is our goalies. 4 would be defenders, so we can put that in red here. The other 4 refers to our midfielders. And then the final 2 refers to our strikers. So I'm going to set up kind of placeholders for them. So we have our goalies, we have our defenders, we have our midfielders, and we have finally our strikers here. Okay. So what's happening here is there's only allowed so many individuals in a position. So we have to figure out how many different ways we can organize these individuals in those positions. So this is where we talk about combinations, and combinations are usually written as an n variable if a combination of r. Have you seen the formula before that looks essentially like this? This is the formula for a combination here, okay? And what it says is it asks, or it sets up, how do you count a certain number out of a total group here. So we'll start with our goalies. Our goalies, there are 2 total. So for our combination, we would say that there are 2 counting 1. So we want to know how many different ways we can choose one person out of a group of 2. So we can put it through this formula here, okay? But we can also pull up a little calculator to help us out. Now your calculator might look a little different. The one I have here, I've already preset it up here. How many ways can we count 1 individual out of 2? And our answer is 2 here. So what that's done is we've counted the number of ways that we can set up essentially goalies. Okay, so the goalie part, I'm going to write the combination on top. How many ways can we count 2? Or 1 individual out of a group of 2. So that's our first number we need to solve for goalies. For defenders, our total group is 6. There's 6 of them, but there's only 4 positions for defenders. So for our combination, we're looking at how many ways we can count 4 defenders out of 6. Okay? So each of these combinations is going to produce a number, and once we get a number for each of the positions, we're then going to multiply each of those values. Okay? So we have to set up the same thing for midfielders. There are a total of 7 midfielders, but there's only 4 positions for the midfielders. So we have to figure out how many ways we can take 4 midfielders out of a total of 7 on our team. And finally, same idea with strikers. How many different ways can we count 2 strikers, because that's how many spots are on the field, out of our total of 3. So each of these is going to give us a value. And we technically need to multiply each of these values together. And that's where the fundamental counting principle comes in. Fundamental counting principle is essentially taking a value and multiplying it by other values across. We used our combination to essentially calculate the values we need, and then we used the fundamental counting principle to get our final answer. So we're going to run through each of these combinations. To choose 1, if we put into a calculator, we're going to get 2. So we have 2 different situations of goalies, and that makes sense. You either have the first goalie in, or we have the second goalie in. For our defenders, let me bring up our calculator here. There we go. Our defenders. So I bring the same idea. I just have to choose 4 out of 6. Okay, and there's 15. So what that's telling us is there are 15 different ways we can choose 4 defenders out of a group of 6. Okay. The next one we're looking for is our midfielders. Our midfielders are very similar. There's 4 positions, but this time there are 7 midfielders to choose from. So 7 choose 4 gives us 35 different possibilities. So there are 35 different ways we can choose the midfielders. And then finally, we have our strikers. And our strikers, they're asking how many ways can we choose 2 strikers out of a group of 3, and there are 3 different ways we can do that. It's telling us, okay? Now, I used combinations because I made the assumption, this is where I was telling you the question is kind of vague. I made the assumption here that the order didn't matter. Okay, so for instance, let's say the strikers here. We'll get into it. I'm going to give them fake names here. Or not fake names, but essentially names. Here's our striker. We'll call striker 1 Mike, 2 Dave, and 3 is Gabe. Okay. What I'm making the assumption is with the combination that if Mike and Dave are the strikers, that's the same as having Dave and Mike as the strikers. Okay. If it isn't, for instance, let's say the left position was important and the right position was important, so they decided to break their strikers to play on certain sides of the field, and it was important, or there was a difference between Dave playing left and Mike playing right, and Mike playing left and Dave playing right, that's when we'd use something called the permutation. I know that you spoke of. And that's the idea of when order matters. I made the assumption here that order didn't matter. But if it did, it's going to give us very different answers, because if we use a permutation instead of a combination here, our numbers are going to be much larger. In fact, this formula is very, very different. Okay? So we just have to kind of keep that in mind. If the order matters, it's going to change our values. So let's calculate and see what we get here as a final answer. So we're looking for 2 times 15 times 35 times 3 should be our final answer here. Okay, so we can take out our calculator again. And we have 2 times 15, whoops, let's make sure we can see those numbers, times 35 times 3. We're looking at 3,150 different ways that we can field our rather large team in that very, very specific formation.